Good morning. My name is Tawanda Mendy. I'm representing Group 3 members. We are going to look at a question on marketing related variables and come up with a multiple linear regression on marketing mix model. So we take this opportunity to do a practical on IBM SPSS. So the first thing you need to do is to go to the variable view, whereby you enter the variables and the type of the variables. All the variables, they are numeric, the width, the decimals, the values, and the measure. The measure is very important because when you are dealing with a multiple linear regression, all the variables must be measurable in terms of must be numeric, right? So the first thing here we have to to define the variables. Then the next we import the data. Already I've imported the data. So here our major aim is to find the effect of these independent variables, advertising through the television, advertising through the radio, advertising through the newspapers. We want to see the effectiveness of these advertising strategies to the sales. So here the sales are the dependent variables. Our sales are the dependent variables. So the TV, the radio, and the newspaper, they are independent variables. We've got three independent variables. So we want to look at the effect of those advertising strategies on the sales. V1 it's on V1 it's like an occasion identifier. As you can see here, we've got 200. We've got 200. Our sample we've got 200. So V1 is just representing like it's our primary key. It's like an occasion identifier where we are saying on this occasion we've got it's occasion 1, occasion 2. So V1 doesn't really affect the sales. So we are going to take the TV, radio, and the newspaper as the independent variables. So if you want to model our multiple linear regression, we go where there is analyze. So under analyze, we go to regression. And under regression, we go to linear. We click linear. So this is the window which is going to pop up. We are going to take the cells like what I highlighted earlier as the dependent. So we push with this arrow. If you want to retain, maybe you've chose the mistake, you do this. Then so our cells is the dependent. Then we highlight the independent variables, the TV, the radio, and the newspaper. Then we push here. So these are the independent variables. After that, we go to the statistics window. So we want our model to be at 95% confidence, which means the level of significance will be 5%. And we also want the descriptives, where maybe we want to find the average sales, we want to find the sample size, right? We can also check on pattern partial correlation. This is on if you want to come up with a correlation matrix. You will see the correlation matrix. Here we can leave it like this. Then we can click continue. Then below statistics, there is plots. So on plots, we are going to plot the graph of residuals. The graph of residuals. So there is Z residual and then the S residual. So this one we put it on the x-axis, then this one on the y-axis. Then we want to show histograms and normal probability plot. These graphs, they are going to help us on identifying whether our data is normally distributed. You know, when we are modeling a multiple linear regression model, there are several assumptions that you need to take note of. So these plots, they are going to help us in concluding whether this data is normally distributed. We can also produce the partial plots where we would see the difference. We have the different variables. We can plot plots comparing the different variables that we have. Then we move to continue. Then we go on to save. So on this save, sometimes we would want to predict the cells. So we click on the predicted values and the residuals. So the predicted values is the result from our model that we are going to come up with. You will see from the original data, there are going to be 2 more additional columns that are going to be produced. We are going to have the predicted values and the residuals. Residuals, that is the difference between the original cells and the predicted cells, the y-hat. Then you can leave the other ones and tick, then say continue. You can go to options. Right, since this data doesn't have any missing values, this window is where you can choose. If you have missing values, you can replace the missing values with the mean, but here we can leave it as at default since we don't have any missing values. So after that, we can proceed to OK. Right, we are going to obtain this outcome. We're going to obtain this outcome. Right, we are going to obtain this outcome. These are the outcomes that we have. But before we look at the outcome, let's go back to the original data set that I highlighted in. Right, this is the original cell where I said we are going to have 2 more additional columns. The first one is for the predicted. The models predicted the cells for us from the TV, radio, and the newspaper. So these cells, they are the original cells, the Y original cells, and this one are the Y-hat, the predicted. So if we have 22.1 as the original, the predicted is 20 point. Then the difference between the original is this one. So as you can see, there's a little difference. There's a little difference in the residuals. There's a little difference. So let's go to the results and see the output if our model is good. So this table, remember where I ticked the descriptive on the descriptive statistics. So this table gives us the descriptive statistics where we are saying we can find the mean cells. Here our mean cells is 14.023. N is the sample size. We have no missing value, so the sample size over here is 200. Then for the TV, the mean contribution for the TV is this one, for the radio is this one, for the newspaper is this one. And here below that, these are the correlation matrix. This is the correlation matrix. We want to find the relationship between the variables. As you can see, the diagonal here is 1, 1, because we are saying cells and cells, obvious, the relationship is 1. But if you want to find the relationship between the TV contribution with the cells, it's 0 point. This one, which is very high, a positive linear relationship between cells, and we are going to look at the model. Then here we have cells and radio. It's almost 0 0.5, which is also strong. It's high, but it's medium. 0 0.5 is between 0 and 1. Then for a newspaper, we have a weak positive linear relationship. You see it is going to be strongly agreed with the result. The next we are going to look at is the model summary. This is our model summary. This is whereby we are going to see is if our model was really a good model or a not model. So I'm going to explain using the write-up. This is the model summary that we have. So the model summary For the model summary, it provides R squared and adjusted R and the standard error, which can be used to determine how well the regression model fits with the data. So this is our table that we obtained. So we have the R column represents the value of R, the multiple linear correlation coefficient, sometimes referred as to the Pearson correlation coefficient. So R can be considered to be one measure of quality of prediction of the dependent variable. In this case, the dependent variable is the cells. So a value of 9.97 in R indicates a good level of prediction. Then the R squared, also referred as to the coefficient of determination, which is the proportion of variance in independent variables that can be explained by independent variables. So in this case, we are saying all the other variables, they contribute almost 89.7 variability in determining the dependent variable, that is the cells, and the remaining, that is 100 minus this one, is also contributing by other factors. We will not talk much about the adjusted R and the standard deviation. Then we move on to the ANOVA table. We have this ANOVA table. We have this ANOVA table. We have this ANOVA table. The ANOVA table is used to define the now alternative hypothesis. Now in alternative hypothesis. So the ANOVA table is there for the statistical significance. We have the F ratio in the ANOVA table. Let me show you. We have the F, the F, that is the test statistic, and the degrees of freedom, which is 3. And the as you can see, the probability of the test statistic is 0.00 something, which is statistically significant, which means we have a good model there. So let's discuss. So the F ratio in the ANOVA table, as you can see below, test whether the overall regression model is a good fit for the data. As you can see, at 95% confidence interval with the degrees of freedom of 3, our value of the test statistic is this one, and the P is 0.00, which is less than the significance level. Right, so the null hypothesis here, we say H naught, all the coefficient, regression coefficient is equals to 0. This clearly, this implies that the regression coefficients or the variables, that it doesn't have any effect on the cells. And this one, H, the alternative hypothesis, we are saying the regression coefficients are not equal to 0. They have a contribution to the cells, the dependent variables. So the BIs, they are the regression coefficients. So the regression indeed is a very good model, since we found that this probability is statistically significant. So we reject this H naught and accept H1, meaning to say the regression coefficients, they have a significance in determining the cells. So that is the ANOVA table. So we are going to come up with a model, the structural model of the multiple linear regression. So we go to the coefficients, the coefficient model. We have the unstandardized coefficients, we have the error, we have the standardized coefficients, we have the test statistic, the T statistic for each variable. We also have the confidence interval for the 95 confidence interval for each and every variable. So as you can see, these are the variables that we are predicting the cells. So we'll be saying cells is equal to 2.939. This is the constant, plus 0.046 TV, plus 0.189 the radio minus 0.01 times the newspaper. Let's see on our write-up. So these are the cells. This is the equation which represents on how we can predict the cells. So it's obtained on the coefficient table. This was the table that I was interpreting. So we can test this statistical significance of each independent variable. This tests whether the unstandardized or standardized coefficients are equal to 0 in the cells. But as you can see from the table, all the cells, all the variables except for the newspaper. We are saying the TV is statistically significant because okay, the TV is a test statistic of 32.809 and is statistically significant. So as you can see again, the radio, the test statistic is 21.89. It is also statistically significant. But for the newspaper, the test statistic is not statistically significant because it is greater than the alpha level of 0.05. That's why we see on the correlation matrix that we have a weak relationship between the newspaper and the cells. And we can also test on the confidence interval. These are the point estimates of the constants, and these are the confidence interval. That's the interval estimates. We are saying this constant lies between we are 95% confidence sure that the constant lies between 2.324 to 3.554, and we are also 95% confidence sure that the TV lies between this and this, the radio lies between this and this, the newspaper lies between this and this. So these are the intervals. We can also go on to the intervals. Let's move on to the charts. These are the charts like what we have highlighted earlier. This is the histogram, and it is almost approximately normal. So meaning to say the data is normal, and the histogram also help us to identify the cell, the outliers. As you can see, we have the outliers here, but roughly the graph indicates the normality. Normality is there. And also you can also use the QQ plots, where we say if the variables are along almost equally distributed along the line, it is also a normal distribution. We also have the scatter plot. These are the partial regression plot, where we have the relationship between cells and TV. As you can see here, we have a positive relationship. If you want to find how strong is it, you can double click it. You can double click it and try to fit a line. We can try to fit a line, the linear line here. You can see the linear line. So the relationship is R squared is almost 0.89, which is a good relationship between cells and TV. We also have the partial between the cells and radio. Again, we have a positive linear relationship between. We can put our line. Yes, as you can see here, it's our regression, the line of the best fit. We have the relationship between the cells and the newspaper. You have observed that there's a weak relationship between newspaper and the cells. So these are the partial plots that I was talking about. So lastly, on our write-up, what is the significance of those coefficients? What are we really saying when we have this, when we have this? when we have this equation. What are we really saying when we have this equation? Here is the interpretation that we have. Results from that equation shows that 1% increase in the radio advert, the sales will increase by 0.536%, right? Whilst like in this case, I'm interpreting on the standard coefficients. As you can see, 0.536, whilst 1% increase in TV advertising strategy on TV spend will result in 0.753% increase in the sales. On the other hand, sales obtained from advertising through the newspaper have a negative correlation, and an increase of the newspaper spend seem to have a zero to or a negative impact on the sales of a coefficient of negative 0.004. So that's how we interpret this structural model of the multiple linear regression. Thank you very much for the attention. Us as a group, 3 members.